All right, welcome back, everyone. So we'll be continuing the series that we have started. I think before a while we have started a series, right? Going from zero to a decent level in language modeling, like large language modeling, the theory and both in both the theoretical and the practical manner. So we have, I think, come to the last video. I mean, definitely like we could go further. I mean, I'll be covering all the research work and all the things, continuation things in this channel also. So check out if you're interested. So this is the last video. So in this video I hope to uh, give you almost like a high level overview of what is happening in the field currently, like what is since the chat gpt revolution, I would call it the LLM revolution that has started with ChatGPT. So after that, what has been happening and why is it not really considered that big? Why is LLMs really considered that big? Like what are some areas, some application areas, some maybe like where LLMs are using? I'll cover that. But I'll also cover some practical manners, like on like what like how to use APIs, how to use large language models, maybe how to train or maybe how to fine tune your own language model, and also some other techniques and also some research work. Right, I'll share with you like what is happening in the research field also. Just to provide a basic overview for you and maybe motivate you or inspire you for your further, maybe increase your further understanding in the field or any further intervention or anything right in the field. So basically, that is what we'll be doing in this video. So first of all, I think it is really nice to I think cover up like what we have done in this I think 4 videos. So over the past 4 videos, we have like covered the basics theory of transformers and also deep learning, what deep learning actually is. And we have covered the idea of neural network, like how like what are the constituents of neural network. We have also covered the optimization algorithm that is the like the driving force of neural networks. Then we also covered we have covered about RNNs, like we have covered time series models mainly. So some models that are you know made or engineered to be like to like predict the flow of time or like information, how information changes over time or sequence. That is the same model or type of model that we have been using for language modeling. And we have also learned, and after that, after learning about RNNs, LSTMs, GRUs, and all that, we have came to transformer, right? We have came to the idea of transformer, how that is a revolutionary idea. Uh, how, like the details we have looked at it, and also we have implemented it in the last video. So in this video, I just want to give you like what happened afterwards. So the attention, the name of the paper is "Attention is all you need," which introduced the idea of transformer. Right, this is the paper that introduced the idea of transformer. It is really released in like 2017 by Google. Afterwards, many large language models that have started to come in, right? Since 2017, or I think probably 2018 or 19, I don't know. But so many companies started to release their models, right? They would have like a huge transformer model, right? They would take a huge transformer, they would build a huge transformer model and like train the model on like the internet data. It basically are like huge data sets, right? A lot of data is presented on the internet. So there's basically, they'll have some powerful GPUs, right? Companies will like buy some powerful GPUs and they would train the large model, large language models or like huge data sets, and they would basically leave these models for everyone to use, right? So one great website in which you could like find all these models is like called Hugging Face. Definitely check that out. So Hugging Face, in which, so in this Hugging Face website, you could like find a lot of models, right? Models that have been trained by um, these models are trained by like huge companies. And what you could do is you could use these models. You could use pre-trained LLMs. So pre-trained LLMs, you will use these pre-trained LLMs for your task, right? For whatever task, because see, internet constitutes of a like large amounts of data, right? Internet constitutes of lots of amount of data, and because of that, the model has a general idea or a general idea of how things work, how language works, and the model can understand your language. And because of that, you could use this advantage. You could use this advantage of pre-training and basically use it for almost any language application, right? Any application that involves the usage of language. For example, you could build maybe like a customer review thing, or like talking to customers. Before maybe before AI, before a large language models, you have to like have actual humans to maybe interact with our customers for any queries or something. But now you could have large language models, right? You could have LLMs that that have access to maybe your company's information database or something. So maybe there's some huge database that consists of, well, information about your company, and you could like use this pre-trained language models and just give these huge amounts of data of your company, and the model can answer whatever query that customer asks based on this huge database. And that is actually quite useful tool, right? Many companies could actually spend a lot of money on that. They could cut a lot of costs and like humans, and basically that would be pretty nice. So that those are LLMs, right? You could use pre-trained LLMs for your tasks, right? And then you could also, maybe when if you want to like make your LLM like more maybe better, right? If you want to make your LLM more better at a specific task, then you could do something called fine tuning, right? So you could do something called fine tuning to make the LLM much better at a specific task, right? You could do that. So what you would do is, you will take that pre-trained LLM, you take that pre-trained LLM, and basically you will train this LLM again. Like you would train this LLM again on a specific task. For example, you could collect some information, right? Maybe something like you want to build something like maybe a linguistical calculator, right? So something like, so let's say you want to build a calculator that works with language, right? Maybe something like what is 4 plus 5, and maybe you want the model answer to 9. Maybe you want a what is 9 plus 15. Maybe you want the model to answer 24, right? So basically, if you want this, let's say that this is an example. Maybe if you want a model like this, you could collect a lot of examples, right? You could collect a lot of examples of prompts and answers, and the model would figure out like what the model has to do, right? The model could figure out what it has to do. uh, right? So I mean, by doing this, the model can understand or get at the starts better. So if you do not like fine tune the model, right? And if you do not fine tune the model might not work very well in this situation, because, well, it is only like trained on internet data. So basically, it will predict random numbers. But here, by doing fine tuning, maybe, right, maybe the model could figure out the relation between the numbers, and like maybe the plus sign. You can understand what happens when there is a plus sign and all that. It could understand, right? Right. So that is what I'm talking about. And remember, right, the more the examples, the better. Of course, you can have more examples. Like sometimes even like less examples will make a difference. But that, well, very well. Anyway, that is called fine tuning. So in like if you want to like train a complete LLM from scratch, maybe in this task, that will take like a lot of examples. You would need like a lot of examples, because the model should understand, well, the meaning of each word, the meaning of each number and all that from scratch. If you want like build a model from scratch without like using the pre-trained LLMs, that would take a lot of time, right? That will take a lot of examples also. But now, using this pre-trained large language models, you could simply give like a little number of examples, 20 or something, and the model could maybe perform very nice. So that is fine tuning. That is the idea of fine tuning. And now you could do fine tuning. You could like fine tune any model, like based on this data, based on your data. I've actually fine tuned a model. I think I fine tuned llama in YouTube channel. You could find that video also. And yeah, I think that's it. That is fine tuning. And then uh, right now, I just wanted to like talk to you about like the future directions, like what is LLMs currently are used for. So so before doing that, before talking about like the current use cases, I just wanted to give a little tutorial, or um, a little lesson on prompting techniques, right? So how to prompt your model. Now that you know like um, the model, like what is pre-training model, pre-trained LLMs, right? You don't know what that means, and what is mean by inference. Inference means like using a model. So now let us discuss some prompting techniques or some techniques or inference techniques, right? You could call them that also. So there are a few type of techniques which are pretty simple. There is zero shot inference, which I'll cover this concept in a very easy manner because these are very simple concepts. Zero shot inference, right? There is a few shot inference, and then there is fine tuning, which I've just talked about, which I'll just recollect. And then we have also something called chain of thought prompting, and of course there are I think many. I think there are many more. Chain of thought process or something. Yeah, I'm sure there are many more, but I'll just cover them on a. I'll just cover this because I think these are the most important things, and also cover some other techniques. One more technique I just want to cover, which is parameter efficient fine tuning. I'll cover that also. So before that, so first of all, let's cover what zero shot inference is. So in the case of zero shot inference, what we'll be doing is we'll be taking a large pre-trained LLMs. We'll take a LLM and directly use it for a task. For example, you can just say, let's say, what is the capital of India or something, anything, right? You just use it directly, right? You not provide anything, any context or any information about the task. I mean, you could provide information about task. So this is one example. What is capital of India? But I'll give you a more better one. I'll give you a better example. Like the model could have a context, I think. So in the case of zero shot inference, you could say something like, yeah, first you could like provide a little context about what the model has to do. So let's say you are a assistant at a assistant or customer or some customer assistant helping customer. You're an assistant for a let's say for a e-commerce company as company, and so answer the following query. Answer the following query or something like that. You could have answer the following query, right? You could something like that. Just provide a little context, like what it has to do. You are that, and this is what you have to do, and we could just provide the prompt, right? Answer the following question, and you could just have the prompt. So basically, you would create this like template. So for like every question, the model will get. You will just add this text before that prompt, and then you will provide the question, like whatever that is, and the model will get an answer, predict you an answer. And since the model is pre-trained, it could maybe perform pretty well. But in case if you want better performance, you could do something called few shot inference. So you could do something called few shot inference. So by the way, this is called zero shot inference because, well, no example is provided, right? You can just understand what that means in just a minute. So in the case of few shot LLMs, you can have an LLM, and the input of this LLM. This is the input, by the way. And the input of the LLM, in the prompt of the LLM, we will not only provide the context, we'll provide the context what the model has to do. We'll provide the context or the job or the responsibility of the model or the role of the model. We'll provide the role of the model, and after that, we'll provide some examples, right? Some example completions. For example, I will provide some examples, right? Here are some examples. Here are some examples. We would write in this prompt, right? We could write it in the prompt, and we could just say here are some examples, and we would pass in some few examples. Right? We could pass in one example saying that it's saying like this question, something like let's say example question and example answer for that question, right? Maybe you could have a lot of data. Maybe you have a company, you have a lot of data. Well, all you have to do is like provide 5 example completions, 5 questions and 5 corresponding answers, and we just provide all these answers in the prompt, right? We are not fine tuning the model or anything. We are not updating the weights of the model. The model weights are not updated. So technically no training here is done, but the model will just gain understanding through these completions, right? And after that, after providing all the completions, right? After providing all the completions, you could just have to ask the question, right? You could ask, right? You could ask your question, right? Whatever your question is, and the model would hopefully give a better answers, right? Now that you have provided context, and you have provided some examples, the model would hopefully perform better. And this is called few shot inference because we have provided the model with a few completions, right? Few example completions. The model could have, a better understanding of the task and perform better based on the completions. And then now we have talked about fine tuning again. So fine tuning, in the case of fine tuning, we do not like do anything with prompting to be precise, but what we do is we try directly train the model, right? We provide the model with examples, and the model will be made to predict for that questions, and based on the predictions of the model, we'll compare the predictions of the model with the actual our answer that is there on the training data set, and would update the model's weights, which are already updated during the pre-training of the LLM on the internet, right? So we'd basically do that, and of course, fine tuning yields better results than few shot inference or zero shot inference. And then we have chain of thought prompting. I guess, yeah, it is chain of thought prompting. So in the case of chain of thought prompting, basically what we'll be doing is we'll also be providing questions and answers, right? We'll in the prompt itself, we'll be providing questions and answers, and let's say we have maybe the question is it's a mathematical question. Let's say something like 2 into 5 plus 6 into 7 or something like that. So if you have a question like this, right, in the case of like few shot inference, or in the case of few shot inference, we would like directly give the answer, which is 5 to the 10 plus 42, 52, right? We'll directly provide the answer. In the case of few shot inference, right, we'll directly provide the answer, right? Again, this could be generalized to anything, or even like let's say text, right? In let's say in the case of text, in the case of problem solving, rather than directly giving the problem and directly giving the answer. So this is directly giving the answer is few shot inference. Whereas in the case of chain thought prompting, chain thought prompting, something like that. So in the case of chain thought prompting, this is chain thought prompting, by the way. In the case of chain thought prompting, we'll be given the same question, right? So in the case of chain thought prompting, we'll basically go through the answer, go through the process of answer, right? These are completions again, right? These are completions that we'll be providing to the model in the prompt. Here we'll basically like have a deep procedure. Like what will happen? We'll provide the model with a deep procedure. So we'll maybe break down the problem into maybe 2 or 3 tasks. We'll calculate 5 into 2 first. Is 10. Would say 6, 7, 42. And we'd say 10 plus 42 is equal to 52, right? This is a detailed way, right? This is a little detailed way. So basically we are breaking the problem into like multiple tasks, and each task is done to do the next task. So this is like chain thought prompting. So while providing the examples, for the model to, well, in the prompt while we are providing the model examples, we would basically not directly provide the answer, but will also provide the model with intermediate steps, or steps that have to be taking place to answer the question. We'll also provide the model with those steps also, such that the model understands better, like just like children, right? In school, rather than like directly providing the answers like we do in normal schools. So not the a little sense of thinking, right? Thinking process takes place, right? We just provide that, provide a detailed way of thinking, all steps that have to be taken. So that is those are some prompting techniques. And then one more thing I want to share now is like fine tuning. In the case of fine tuning, one like I think one research field, or one field which have been taking place in the research world, is like reducing the computation complexity required for fine tuning model. Fine tuning also, like, think of large language models, that you have many weights. The model consists of many weights. So therefore, since the model consists of many weights and like many layers, of attention and layers, multi-attentions, many encoders, many decoders, many weights are involved, right? Many weights should be updated while fine tuning the model. So basically, when you are fine tuning the model, in order to like decrease the computational complexity, many research papers have been coming out, many research things have been coming out. So please check that out. Please look out for that. So one website I would absolutely recommend you to be to stay in touch with the field, not only language modeling but also computer vision, like image model, maybe image generation models, diffusion models, stable diffusion, etc. So in order to like stay in with the AI research, so one website is Papers with Code. So you can read new papers that have been coming up, new and trending papers, and also you could maybe take a look at the code behind that, some implementation. You can also take look at some implementations behind that. uh, it's a great website, right? You could look at that. So basically this is a great field, reducing computation complexity. One model that have been that have came one approach that have been came up is something called LoRa. I think it is low rank metrics or something. Low rank what is it? Low rank, yeah, something low rank fine tuning or something, in which I think we train only few amount of weights, like only some percentage of the total weights of the model. Check out for that also. I think I'll make a video in the future, or maybe in the next video I'll make it. So right, so that in theory, right? And then coming to like what is happening in the field recently. Well, I think I'll tell you, like a lot has been happening, right? Fine tuning has become one thing, and also like multi-model language modeling, in which not only text but also images and like videos and audio can also be inserted. So in the case of language modeling, only the model only learns the relation between like text and text. So between words will perform the attention, and only words can be understood by the model. Well, there is multi-model language modeling, in which uh, data of different sources, of different types of sources, such as images, videos, websites, or even audio, they also can be understood by the model in relation to the text. So basically, while you are having a conversation with your model, you could insert a random image and maybe talk about that image, and also you could insert a random video and maybe talk about that video, and or songs, listen, maybe insert songs to the model and then in the conversation. So you could do that, right? Multi-model language models have been coming up. So one model that I've recently come across is, it's called something called Next GPT. uh, I was I think I have done a paper review, right? Paper I think walkthrough in my YouTube channel. So check out if you are interested. That is one area, and the second area I think is code completion, like completing programs, software development. So recently I saw another paper called Chat Dev, which was able to like complete the which was able to like finish the complete software development, software development pipeline, or like finish software development in like 7 minutes, whereas I think a human engineers would like take months of work. This model could like do it like very short time, and at a very short cost. So basically they'll use the power of language models, and they'll use chain of thought prompting. Right, so the one I just told you, I think they'll use chain of thought prompting, that technique on a very high level, to actually build a model that could like complete code, like finished code, not only finished code but like build code. We just provide the description of the software, and the model will build that software for you. I mean, it could be quite scary for like software developers, but you know I mean we're just filter routing many jobs as we go on, as even new technologies come up. A lot of jobs are getting wiped out. I mean, I think that a lot of jobs are just filtering out. So mainly maybe the futuristic jobs, and maybe jobs that are less done will be encouraged, or will stay. Um, and yes, so that is very interesting field. I've made a video of that model also, Chat Dev. Check out if you are interested. Then yeah, and these are some latest papers. Again, Papers with Code, very useful website. Check out if you are interested. What is that? I mean, there are many like, so yeah, modeling complex mathematical reasoning via large language model based math agents. And they're quite interesting papers. Check out if you are interested. Like there a lot of models has been come out, and again, Auto GPT. I mean, I think you definitely would have heard about the model, right? I think it is like the most starred GitHub repository. Like in GitHub, you could like provide stars, and yeah, there are like 155,000 stars for this GitHub repository. So what AutoGPT is that in the case of ChatGPT or other language models, the model only has has access to old data, from up, until the model, until when the model has been trained. So AutoGPT has access to internet. AutoGPT can also like break the process, just like chain of thought prompting. It could like break the process into many steps, and it could carry out all the intermediate tasks. So basically, no human intervention is also required while the model is doing a task. So which is actually quite nice, and also got like pretty popular. Uh, so definitely check out if you are interested. So yeah, I mean that's it. I think that's it for this video. Hope you enjoyed, and hope you have got maybe a little amount of information, usefulness from this video. So thanks for watching, and I will see you in the next one. So, and it has been a great series we have done. So I think we'll be moving on to research work. I mean, we will be taking a look at models, and feel free to comment what you want to listen to or what you want to learn. Thank you.